Here we go, everybody. Just as a heads up, we're doing a test next Friday, so a week from today. Today's the last new material, so then we practice it today and Monday and Wednesday, and then we have a test on Friday. We're going to do conversion problems. Let me give you an example. Let's say I gave you 1,000 seconds. I'm going to be asking you to convert that into hours, minutes, and seconds. And then another example would be, let's say I give you 1,000 pennies. I'd like to know how many dollars, how many quarters, nickels, dimes, and pennies. We're not going to do dollar coins or 50-cent pieces. But anyway, to do this sort of thing, you have to use modulo and division. So here's an example. I'm just going to show you how to do it. Let's say somebody has this code, int seconds equals scan.nextInt. And to find the number of minutes that are in those seconds, all you have to do is divide by 60. And we're not worried about a decimal remainder because remember, it's integer math. So if it was 60, we would get 1. If it was 100, we would get 1. Jack, will you go get some paper towel and that spray and clean that up? Maybe throw your can away at the same time since it seems empty. It's not empty? No. Okay. Folks, if the seconds value was 61, it would still just be 1 minute, right? You're dividing, it throws away the remainder. It's perfect. It's just what we want. And then, here's an example. If I entered 100, I'd get 1 in the minutes variable. And now, seconds is still 100. So here's how we fix that. We got to get rid of those seconds that got taken up by the minute. What we do is say seconds equals seconds modulo 60. Because remember, modulo gives you the remainder. So first we're dividing by 60, and whether it was 1 or 5,000, you're going to get all those 60s. And when you do modulo with 60, you're getting the remainder. Every little second that wasn't included in a full minute is all that we have left. So if we did the 100-second thing, now minutes would be 1 and seconds would be 40, which is true. That's how it works. So imagine if you were doing hours and then minutes and seconds. For hours, you'd have to do 60 times 60 or 3,600 because there's 60 minutes in an hour and 60 seconds in every minute. So, I just did it for hours. I didn't know I was going to show you. So we're still getting the seconds. We're saying, hey, hours is seconds divided by, and you have to use parentheses there if you're going to do 60 times 60. I left it 60 times 60 just so you weren't just like, where'd the 3,600 come from? But if you use 3,600, you don't need to put parentheses around it. And then you have to do the modulo to get the hours out of the seconds. And then you do minutes is seconds divided by 60, and then you do the modulo to get the minutes out. So anyway, you'll have this slide deck in just a minute. Any questions? So if you were going to do money and I wanted to know how many quarters, nickels, and dimes, you'd be doing divided by 25. You know, if you start with pennies, divide by 25, that's how many quarters you have. And then you modulo 25, and then you divide by 10. You have to work your way down. You can't start with nickels and work your way up because there'd be a lot of nickels if you didn't have any quarters. That's it for conversion problems. You're going to have a problem where you have to do that with money. Now we're going to talk briefly about nested for loops. That's when you have a for loop inside of a for loop or a while loop inside of a while loop. So I guess it's nested loops, not nested for loops. So when a loop is inside another loop, one important thing to know is the inner loop has to finish its job completely before the outer loop gets to go again. So if you have an outer loop that's a for loop and X is going to go 1, 2, 3. When X is 1, you come in and then the whole inner loop is going to do its thing and X is always 1. And then the inner loop finishes and then you go back to the outer loop and do the next number. So it's important to know that things finish before on the inside before you get to do the outside again. I'm going to ask you now to try to tell me how many stars get printed on this. And I'm going to call on somebody. Don't raise your hand or anything. 15 is right. Wow. The outer loop's going to do 5 times, and each time the outer loop runs, the inner loop runs 3 times. Next up, Jack, I'm going to ask you, so I want you to try to come up with a good answer.
All right.
And I'll let you pass if you want to pass, but do you have an answer?
Is it 6?
No.
Okay, pass this.
I want to, oh, somebody besides August. Great.
Is it like 0, 1, 2, 3, 4, 3 times?
But could you say that a better way? Yeah. I mean, it's 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. Yeah, so it's not 0, 1, 2, 3, 4, 5 or 0, 1, 2, 3, 4, 5 times. It's 0, 0, 0, 1, 1, 1. Let's look. I is 0. It comes in. You know this is going to repeat 3 times. We're not even using J, but just that's okay. This makes it repeat 3 times, and we're printing I 3 times. So 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. All right, another one. Larry, I'm going to ask you. Can you give it a try? By the way, it might help to have paper out for this. And you can pass. This is harder. I'm not trying to embarrass you. I just have feeling like there's a lot of buzz. Certain people like Jack and you were busy doing other things, so I was calling on you to pick on you. I want you guys to pay attention. Let's talk it through. When I is 0, we come in. It says, hey, J is 0, and we're going to do the inner loop as long as J is less than I. 0 is not less than 0, so it doesn't even run the first time. So then it's going to print a space. It's going to definitely print the space, and then it pops back up. I is now 1. We come in. J starts at 0. As long as J is less than 1, 0 is less than 1, we're going to print I. So it's going to print a 1. Just once. Then it prints a space. And we go back out to the top. I is 2. Come on in. And J is going to be 0 and then 1. But we're printing 2. So we're going to print 2, 2, and then a space, and so on. So what you can't see is there's a space in front of the 1, but I wouldn't put a problem like that on the test where there was a space in front of the 1. And there's no zeros because, as I said, when I is 0, then J starts at 0, so it's not less than 0, so it doesn't ever print the 0. Questions?
Is J not a throwaway variable?
Yeah. See, I declare it right here. J only exists in this for loop that has 1 line in it. So right, these 4 lines of code are where J exists. Yeah. Poor Jay. No, Jay got to live. My advice, people, how do you figure these things out? Get out a piece of paper. So let me show you. I don't have paper that I could show you, but you could do, I do this on my paper. So I say, okay, I is going to go 0, 1, 2, 3, 4. Okay, and then I'm going to start the loop. I equals 0. Now, J, not going to run. Because J starting at 0 is never less than 0. Okay, so now I equals 1. And then, I do it. It's easier to do on a piece of paper than on a notepad. But however, you're going to have to figure out a system that works for you. But these problems are going to come up. So I recommend get out a piece of paper and diagram it. What I just showed you. So figure out all the possible values of the outer loop, and then take one of them and do the inner loop, and then take another and do the inner loop. And sometimes you can see a pattern and go, oh, I can see. We're just making a bunch of dots or stars, and I can figure this out. But otherwise, sometimes you got to just do it the hard way. It's okay. Any questions? So really, this wasn't anything new. I I wish I could remember how many slides I have, but I can't. But here we have another example. I'll let somebody volunteer, but give everyone a minute. So remember what I just suggested. You figure out all the possible values of the outer loop just first. Hey. Yeah, I do.
Okay. Mr. Patrick was asking if you had one because I something I needed to nail down.
Okay. Can't possibly do it now, but we could talk another day. I can't. I'm in the middle of something, but yeah. Yeah. What's your name? Eric. Yeah. So I can talk with him and we can talk. Outside loop could be 1 or a 2, right? I'll call on you in a sec. Inside loop. Look, we're going down this time. So it starts, J starts at I. So I is 1. J's going to be 1 or 0. But we're only printing I, so we're going to print 1, 1, and then a space. What do you got, Brendan?
Pretty sure it's 1, 0.
2,
1, 0. That's what I was going to say.
So I will be 1 and then 2, and then J will go 1 and 0, and then 2, 1, 0. So we're going to get 1, 1, 2, 2, 2, with spaces. There's going to be problems like this on the AP test. There's going to be problems like this on your test in a week. So you want to practice diagramming. And all right. This one, I'm telling you, I guess it's timetables. We did one like this the other day. I goes from 1 to 4. J goes from 1 to 4. And look, inside we're printing I times J. So it'll be 1 times 1, 1 times 2, 1 times 3, 1 times 4, and then a new line, 2 times 2, 2 times 1. Anyway, prints this out. So you could go, oh, what's 3 times 3? It's 9. Or what's 4 times 4 is 16. Or 4 times 3 is 12. All right. So we're going to practice. I think, remember, is that really all that we have today? Pennies, nested loop, and coding bat, 6 problems. Yeah. So I'll stop the recording.